All right, guys. So I'm going to continue our thing of optimization problems, and so this is a different type that you're going to see. Okay, I call these ones number problems. Find two numbers whose sum is 16 and whose product is as great as possible. Okay, so we're going to say let x and y be the two numbers. So what they're saying is whose sum is 16. Okay, so that means that x plus y equals 16. So here's question number one. Now, what they're saying is the product is as great as possible. Okay, so the product is when you multiply two things together. So I'm just going to write P for product equals x times y like this. Now the problem that we have right now is we have too many variables. We have a P, an x, and a y here. So what I'm going to do is I'm just going to go and subtract x from both sides of this equation and get 16 minus x equals y. And now we're going to make a substitution. 16 minus x goes into this question over here. Product equals x times 16 minus x. So product equals 16x minus x squared. So now it comes down to the same thing that we did last one. If we want to figure out the maximum, we need to complete the square to figure out what the vertex is going to be. So product equals negative x squared plus 16x. So what I'm going to do here is I'm going to factor out a negative out of these two terms. P equals negative x squared minus 16x. And now I need to complete the square. Half of negative 16 is negative 8, squared is 64. If you can hear that, this is my daughter singing from Frozen. She sings about as good as I do. All right, so I have a 64, but it's really negative times 64, so it's negative 64. I have to add a positive 64 to balance. It means product equals negative x minus 8 squared plus 64. Okay, so what this is telling us is that the maximum product is 64 when x equals 8, because the vertex is 8 comma 64. So therefore, x equals 8, and that means y equals 16 minus 8, or 16 minus 8, which is 8. So this question is the two numbers are 8 and 8. All right, I'll move on to the next one here in a second, guys.